Good morning, students. Today we are going to discuss about the different types of sets, that is about finite set, infinite set, singleton set, empty set, powered set, disjoint set, proper subset, subsets, universal set, equal sets and equivalent sets. Let us start with the finite set. Finite set. A finite set is a set that has a countable number of elements. A finite set means the number of elements in that set should be countable. For example, set A having the elements as A, B, C, D. So, how many elements are there in the set? Let us count 1, 2, 3 and 4. So, it has 4 number of elements. That 4 means the number of elements is here countable. We are able to count the number of elements. 4 elements are there. We are saying the count of the elements. So, this is a finite set. This is a finite set, and we can write the number of elements of the set as n of A equals to 4. Here n of A means n for number of elements in set A. N of A is equals to 4. It represents that the set A has 4 elements. This number 4 is called the cardinal number of the set. Cardinal number or cardinality of the set. That means the number of elements of the set. So it is 4 means it is countable. So we can say that set A is a finite set. One more example. Set Z is having all the factors of 20. What are the factors of 20? So 20 factors for 20 means it will divisible by one table. So 120s are. So 1 and 20 both are factors, and in the same way 2 tens are 20 and 4 fives are 20. So these are the factors. So we can write Z equals to the elements are 1, 2, 4, 5, 10 and 20. These are the factors. This is the set builder form and this is the roster form. So Z equals to 1, 2, 4, 5, 10, 20. How many elements are there in the set? N of G equals to means number of elements in set G equals to, count the elements now, 1, 2, 3, 4, 5, 6. 6 elements are there. Means the number of elements is here countable. So we are counting the numbers. The number is 6. So this is a finite set. And let us see one more example. X is the set of colors in the rainbow. X is the set of colors of the rainbow. So X is having the elements of the colors of the rainbow. So we have to check whether it is finite or not. How many colors are there in the rainbow? 7 colors are there. So 7 is a countable number. So X is a finite set. So this is aquarium and some fishes are there here. So let us count how many fishes are there here. 1, 2, 3 and 4. So this aquarium having 4 fishes. So 4 is a countable number. So this is a finite set. Infinite set. An infinite set is a set which has uncountable number of elements in it. Uncountable means infinite, means we are unable to count the number of elements of that set. So it is called an infinite set. Let us see some examples. Set B equals to X such that X is an even number, means that set B is having all the even numbers. So let us write the even numbers. Set B equals to, even numbers means the numbers which are divisible by 2, means 2, 4, 6, 8, 10, 12, 14 like that. But the even number will not stop by 14. It will go on 16, 18, 20 and so on. We cannot write all the even numbers because it has no end point. So let us write like this and close the bracket. So B equals to, here we have written the elements 2, 4, 6, 8, 10 and 14 like that. Now, what is the number of elements of this set? Cardinal number of this set. So, let us try to count the number of elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what about the remaining number of elements? So we are even unable to write all the elements, so it is not possible to count the number of elements. So that number of elements, the cardinal number of the set is infinity. See here we have infinite number of elements, means uncountable. So this is an infinite set. Infinite set. One more example: j equals to x such that x is a multiple of 7. Multiple of 7 means we can write the elements of j as multiples of 7, means 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28, 7 fives are 35, and like this we can write the numbers. Where we can stop these numbers? So it will go on: 7 6 are 42, 7 7 are 49, like that. So we cannot write all the numbers. So we cannot count the number of elements of this set. The number of elements of this set is uncountable. So this is also infinite set. So the natural numbers set n, and whole number set w, and integers z, and rational number set q, irrational number set q dash, and real number set R, prime number set P, even number set, odd number set. All these are examples for infinite sets. A singleton set. Singleton set is a set which has only one element present in it. Singleton set means it should have only one element in it. For example, set A equals to even prime number, means A is having the even prime numbers. So let us write what is the even prime number. So even prime number is nothing but 2, because the prime number set is 2, 3, 5, 7, 11, 13, 17, 19, and so on. So from these prime numbers, 2 is the only prime number which is even number also. So even prime number is nothing but 2. So how many elements are there in this set? N of A equals to number of elements in this set is 1. Only one element is there. So it is having only one element. So we can say that this set A is a singleton set because it is having only one element. See in this diagram, if we consider this aquarium as a set and the number of fishes is the number of elements of this set, how many fishes are there? Only one fish is there in this aquarium, only one fish. So we can say that this is a singleton set. Empty set or null set. Empty set is a set which has no elements in it, means the set should not have any element. Empty set is also known as null set or void set, and empty set is denoted by phi. This is the symbol we have to use to represent the empty set. For example, set B is having the elements like students studying 7th class and 8th class, 7th class and 8th class in the same year. So set B equals to, so we have to identify the students. For set B, the student should study 7th and 8th class in the same academic year. Is it possible? Can any student study 7th and 8th class both in the same year? No, it is not possible. That type of students will not be exist. So the elements of the set is empty. So there is no students like that studying 7th and 8th in the same year. So there are no elements in set B. So this is an empty set because elements are not there. The set has no elements in that set. So it is empty. And what is the cardinal number of this set? n of b equals to means number of elements in that set b equals to, so it has no elements, so the count should be 0. Here 0 means the count of the elements, number of elements. So it has no elements means 0 elements. One more example, set a equals to a such that a is a number greater than 5 and less than 3. So we have to write the elements for set a which satisfies it should be greater than 5. Greater than 5 means the number may be 6, 8, 9, 10 like that. But the number at the same time it should be less than 3. Are these numbers less than 3, 6, 7, 8, 9? No, it is not possible. Means we cannot choose a number which is greater than 5 and at the same time less than 3. That is not possible. So there is no element in the set A which is satisfying the given two conditions. So the set A is also an empty set. Here, if we consider this aquarium as a set and the fishes in this aquarium are the elements, okay, then the number of elements means the number of fishes in this aquarium is the number of elements. So have you observed any fish in this aquarium? No. So this aquarium has no fishes means 0 fishes. That means this set has no elements, so it is an empty set. And this empty set is denoted as phi, means that empty set means which is having no elements in it, we can represent it with a symbol phi. We have to read it as phi. Phi means it is an empty set, means it has no elements. State which of the following are empty and which are not. So first one, the set of lines passing through a given point. The set of lines passing through a given point means suppose this is a given point and the set of lines passing through this given point means, so we can draw one line like this and we can draw one more line like this and another line like this, another line like this. So in this way, so the lines are infinite number of lines passing through the given point. So this is not an empty set. And the second one, the set of odd natural numbers divisible by 2. So we have to identify the numbers, the natural numbers, odd natural numbers which are divisible by 2. Actual, as per the definition of odd number, it should not be divisible by 2. But here it is given that odd natural number divisible by 2 means it is not possible. So we cannot identify any natural number, odd natural number divisible by 2. So we cannot get an element like that. So this set will be empty. Third one, x is a natural number, x less than 5 and x greater than 7. Means the number should be a natural number, it is less than 5 and at the same time it is greater than 7. So that is also not possible. So this is also an empty set. Fourth one, x is a common point to any two parallel lines. As per the definition of parallel lines, the lines have no common points, means the lines do not touch each other. But here x is a common point to parallel lines. So that is not possible because parallel lines means they do not have a common point. So this is also an empty set. And fifth one, the set of even prime numbers. That set of even prime numbers, even prime number is 2. So in that set one element is there, 2. So this is not an empty set. And in the second question, state whether the following are finite or infinite. So we have to identify the given sets whether it is finite or infinite. First one, the set of months in a year. How many months are there in a year? 12 months are there. Means in that set, 12 elements will be there. January, February, March, like up to December. 12 elements are there. So 12 is the countable. So this is a finite set. And second one, the set having elements 1, 2, 3 and so on 99 and 100. That means this set has 100 elements. 100 is the countable number. So this is a finite set. Third one, the set of prime numbers smaller than 99. Prime numbers smaller than 99. That means the total number of prime numbers smaller than 99 is also less than 99 only. So it is also countable. So this is a finite set. The set of letters in English alphabet. How many letters are there in English alphabet? 26 letters. So the elements, the count of elements is countable. So it is also a finite set. The set of lines that can be drawn parallel to the x-axis. This is the x-axis, and in the set having the lines parallel to the x-axis. So parallel to the x-axis means we can draw the lines like this, parallel to the x-axis. In this way we can draw infinite number of lines parallel to the x-axis. So this is an infinite set. The set of numbers which are multiples of 5. Multiples of 5 means we can write 5 ones are 5 twos are 5 threes are 5 fours are 5 fives are like that. But where we have to stop these multiples, we can write like this, continue. We 6 are 30, we 7 are 35 and so on. So this is also an infinite set. Next one, the set of circles passing through the origin. The set of circle passing through the origin 0 comma 0. This is x-axis and y-axis. The intersecting point of these two axes is origin 0 comma 0. Now we have to identify the set of circles passing through the origin. So passing through the origin means we can draw a circle like this. The circle passing through the origin. And in the same way we can draw one more circle by increasing the radius. And we can draw one more circle like this. And another circle passing through the origin like this. We can draw infinite number of circles which passes through the origin. So this is also an infinite set. Universal set. Universal set is the set containing all elements under consideration in given context. Universal set means it is containing all elements. For example, if the discussion is about the students of a specific class, that means if we are discussing about the boys and girls of a specific class, means boys one set and another set of girls, then the universal set is nothing but the all the students of that class. And second example, if the discussion is about the vowels and consonants, if vowels is one set, is a set, and consonants is another set, consonants is another set, then the universal set of these two sets is nothing but English alphabets. Means these two sets will be in this universal set. In the same way we can write some examples. If set A equals to having elements 1 2 3 and set B equals to having elements 4 5, then the universal set we represent it with the U, and universal set is having all the elements of these two sets. That means universal set is 1 2 3 4 5, and it may have some more other elements also. One more example, universal set U having elements 1 2 3 4 5 6 7, and two sets A having 1 2 3 elements and B having 4 5 elements. Always universal set will be represented by a rectangle. Universal set will be represented by rectangle. Here we have to mention it as U. That means it is a universal set, and the sets should be represented by circles inside this rectangle. Like this is set A and this is set B. And what are the elements in set A? 1, 2, 3. So the element should be written inside this circle. Means the circle represents set A having elements 1, 2, 3, and another circle represents set B having elements 4 and 5. So this is called the Venn diagram of the given sets. But if you observe, in the universal set we have 1, 2, 3, 4, 5, 6, 7 elements. By this diagram, the two sets AB are lies inside the rectangle, means inside the universal set. That means 1, 2, 3, 4, 5 elements are already in universal set, and two more elements are there in the universal set, that is 6 and 7. So we have to write those elements outside the circle but inside the rectangle. So here you can observe, in the rectangle means the in the universal set, the elements are 1, 2, 3, 4, 5 and 6 and 7. So this is the Venn diagram of the given sets. Subset: if each element of set A is present, that means belongs to set B. Means if each element of set A belongs to set B, then set A is called subset of set B. If A is subset of B, it will be written as A subset B. We have to use this symbol to represent the subset, means A subset of B. For example, here we have taken two sets, set A having elements 1, 2 and set B having elements 1, 2, 3, 4. So as per the definition, let us check here what is given here in the definition. Each element of set A belongs to set B. So let us check. 1 is an element of A that is already present in set B, and the element 2 is an element of set A. This is also present in set B. Means all the elements of set A are present in the set B. So we can say that the set A is subset of set B. The set A is subset of B, and we can write it as A subset B by using this symbol. One more example. Here two sets are there. Set A having elements A, B, C, and set B having elements A, B, D, E, G. Now let us check whether all the elements of set A belongs to set B or not. See, the first element A present in set B, and the second element B also present in set B, but the third element C is not present in set B. C does not belongs to set B. That means only the two elements AB belongs to set B, but the element C does not belongs to set B. So we say that A is not a subset of B. A is not a subset of B because one element of A does not belong to set B. So we can represent it as A is not subset of set B. So remember the definition. Each element of set A means all the elements of set A should be present in the set B. Then only we say that the set A is subset of set B. Remember this formula. If A is a set, then the number of subsets of set A equals to 2 to the power of n of A. N of A means the cardinal number of set A, means the number of elements of set A. For example, set A having three elements A, B and C. Three elements are there in set A. So the cardinal number means n of A equals to, means number of elements in set A is equals to 3. So the number of subsets, of set A, the number of subsets of set A equals to, what is the formula? 2 to the power of n of A. that is 2 to the power of n of a. So it is equals to 2 to the power of n of a means number of elements in set A. 3 elements are there. So 2 to the power of 3. 2 to the power of 3 means you have to write 2 for 3 times and multiply 2 into 2 into 2. So it is nothing but 8. So we can write 8 subsets for the given set A. The subsets are, we can write small a as an element one set, and b as another subset, and c as another subset. Means the given set is with elements a, b, c. So writing each single element as a subset. So here 3 subsets are over, and next now write two elements as subset, set A and B, one more subset, and next subset B and C, and another subset A and C. Now the subsets with the 2 elements from set A, and now write the 3 elements, set A, B and C. See how many subsets are here? 1, 2, 3, 4, 5, 6 and 7. These 7 are the subsets, and as per the formula we have to write 8 subsets. So these are the 7 subsets, and the 8th subset and the another one is nothing but the empty set. So empty set is a subset of every set. So with this total 8 subsets are over. If we write all these subsets in a set, okay, so here we got 8 subsets of set A, and if we write these 8 subsets as an elements of another set, means all these subsets are in another set. Now this set is called the power set of set A, power set of that set A, and we can represent it as P of A. P of A means power set of A. Means power set means it is having the subsets as the elements. So the number of elements in power set of A is also equals to 2 to the power of n of A. The number of subsets and the number of elements in power set of A both are equal to 2 to the power of n of A, because the elements of power set A is nothing but the subsets of A. And if you observe, from the 8 subsets, one subset, one subset this subset is exactly equal to the given set A, B, C. So other than this subset, the remaining 7 subsets are called proper subsets, are called proper subsets. Okay, so from the 8 subsets, one subset we have to remove, that which is exactly equal to the given set, and the remaining subsets are called proper subsets. The number of proper subsets of set A equals to 2 to the power of n of A minus 1. Remember the formulas again. If A is a set, then the number of subsets is 2 to the power of n of A, and the number of elements in power set P of A equal to 2 power n of A, and the number of proper subsets of set A equals to 2 to the power of n of A minus 1. If set A is subset of B, then we use this symbol. If A is proper subset of B, then we use this symbol. So that is mentioned here. This symbol is used to denote the proper subset, and this symbol is used to denote the subset. From exercise 2.3, let us solve one question. Fifth one, list all subsets of the following sets. So here one set is given, named as B, and it is having 2 elements. That means n of B equals to means cardinal number of this set B, means the number of elements in set B is 2. Two elements are there, P and Q. Now we have to write the subsets for this set. So the number of subsets equals to, what is the formula? 2 to the power of n of, the set name is B, so we have to write here as B. So the number of subsets equals to 2 to the power of n of B, that is equals to 2 to the power of, what is n of B? 2. So it is equals to 2 to the power of 2 means 2 into 2, it is equals to 4. That means the set B has 4 subsets. So what is the set B? Set B is P and having elements P and Q. Now the subsets are, so let us write the subsets. The subsets are, first we have to write the empty set, and next we have to write subsets with single element from the set P and set Q. And now with the two elements, set P comma Q. See, 4 subsets are here: empty set with element P, set with element Q, and set with elements P and Q. These are the subsets. If we have to write only the proper subsets, means not all subsets, only proper sets, so we have to write the empty set and the sets with single element, set P and set Q. Enough. The proper subsets are only 3, because this set P comma Q is exactly equal to the given set, so this is not a proper subset. We have to write the remaining all other subsets. So number of sets is 4, and number of subsets is 4, and number of proper subsets is 3. If we have to write the power set of the given set B, you have to write all the subsets, means all the 4 subsets. This one empty set, and the single element sets P and Q, and this one also. You have to write all the 4 subsets and keep them in another set. So this is the power set of set B. Subsets means you have to write all the 4 subsets, and proper subsets means only 3, and power set means you have to write all the 4 subsets in another set. Let us solve one more question. Set D having 4 elements, A, B, C and D. So n of D equals to, means the number of elements in set D equals to 4. So the number of subsets equals to 2 to the power of n of D, because the name of the set is D. So it is equals to 2 to the power of n of D is nothing but 4. That means 2 power 4 means we have to write 2 for 4 times and multiply 2 into 2 into 2 into 2. So it will be 16. Means the given set D with the elements A, B, C, D has 16 subsets. 16 subsets. Let us write the subsets. The subsets are, we have to write the 16 subsets. So first you have to write the empty set, and next the sets with single elements, set A and set B and set C and set D. Next let us write sets with two elements. First A and B, A comma B, and then next A comma C, and then next A and D, A, D. Next set with elements B and C, and then next set with elements B and D, and elements with set C and D. Now write the elements with 3 elements. Now the subsets with 3 elements, A, B and C. A, B and C. And then next A, B and D. A, B and D. And A, C, D. And next with elements B, C, D. Now the set with given all four elements, set A, B, C, D. Now these are the 16 subsets of given set D. Here the total number of subsets is 16, and proper subsets means you have to remove this subset because this subset is exactly equal to the given set. So number of proper subsets means 16 minus 1, so it is 15. Number of subsets is 16, means to find the number of proper subset you have to subtract 1 from the 16. 16 minus 1, it is equals to 15. If you want to write the power set of the given set D, you have to keep all the subsets in another set and write P of D here. Means all the subsets are as the elements of another set, then this set is called a power set of given set, and it is also having 16 elements. In the same way, try to write the subsets for these two sets also. Set E having 4 elements, 1, 4, 9, 16. So the number of subsets for this set is 2 to the power of 4, means 16. And F set having 3 elements, 10, 100 and 1000. The number of subsets for this set is 2 to the power of 3, so it is 8. Equivalent sets. Equivalent sets means the sets which have the same number of elements present in them. The number of elements should be same. It is important to note that the elements may be different in both the sets, but the number of elements present is equal. If, for example, here two sets are there, set A having 5, 6, 7, 8 elements and set B having the elements as A, B, C, D. From these two sets, what is n of A? N of A means the number of elements in the set. 4 elements are there, so n of A equal to 4. And for set B, n of B equal to means the number of elements in set B equal to, here also 4 elements are there. So the number of elements in both sets is equal to 4. Therefore, we can say that these two sets are equivalent sets, means the two sets are equivalent sets. We will represent equivalency with this symbol. Here, you remember the elements may be different, but the number of elements, the count should be equal. Then we say that the sets are equivalent. One more example is given here. Here two aquariums are there. Let us consider the first aquarium as set A and the second aquarium as set B. And the fishes are the elements of these two aquariums for these two sets. The number of elements is nothing but the number of fishes. So how many fishes are there in set A? 4 fishes are there. Means number of elements of set A is 4. Here n of A equal to 4. And if you observe the number of fishes in set B, means in another aquarium, so number of elements, number of fishes in set B also equal to 4. Here the fishes may be different. The fishes from both aquarium are different, but the number of fishes, the count is equal. 4 fishes in first aquarium and 4 fishes in the second aquarium. So here we can say that the two sets are equivalent sets. Equal sets. Two sets having the same elements and equal number of elements are called equal sets. For example, set A having elements W, O, L, F and set B having elements F, L, O, W. Here, if you observe that the number of elements in set A is equal to 4 and the number of elements set B is also equal to 4, each set having 4 elements. Here, if you observe, the elements of A and elements of B are equal. Suppose say W lies in the both the sets and O is also in both the sets, L is also in both the sets and F is also in both the sets. That means all the elements of set A belongs to set B and all the elements of set B belongs to set A. So we can say that these two sets are equal. So we can write A equal to B. Okay, again you can remember the definition. Two sets having the same elements and equal number of elements are called equal sets. And we can define this equal sets in another way, that if A subset B means each and every element of set A belongs to set B and B subset A and each element of B belongs to set A, then the two sets are equal sets. A equals to B. Here the order of the elements doesn't matter. The element should be equal from both the sets. So we can say that A equals to B. Let us solve the questions from exercise 2.3. The first question is, which of the following sets are equal? Here three sets are given, set A and set B and set C, but the given sets are in set builder form. To check whether the sets are equal or not, first you have to write them in roster form. See, suppose set A equals to, what is given here, letter in the word follow. The letter in the word follow. That means A equals to F, O, L and L second time it is there in the word, but you have to write only one time, and O is also already written, and now we have to write W. So these are the letters of word follow. And next set B equals to, it is a letter in the word flow. So the letters from that word are F, L, O and W. And the next set C equals to letter in the word wolf. So W, O, L and F. So if you observe that the elements of these three sets are equal, F, O, L, W. Order may be different in the sets, but the elements are same. So we can say that the three sets are equal and we can write A equal to B equal to C. Second question, consider the following sets and fill up the blanks with equal to or not equal to, so as to make the statement true. See, in set A with the three elements 1, 2, 3 and B is given as the first three natural numbers. First three natural numbers means 1, 2, 3. And set C with four elements A, B, C, D and set D is with a D, C, A, B and E with elements A, E, I, O, U and F means set of vowels in English alphabet. English alphabet means vowels means we have to write A, E, I, O, U. Okay, now we have to fill in the blanks. Set A and B are given. Set A having 1, 2, 3 and set B is also having the same elements 1, 2, 3. So I have to write here equal to symbol. And set A and E are given. Set A having 1, 2, 3 and E is having A, E, I, O, U. The elements are not equal. So I have to write with not equal to symbol. And C, D sets are having the same elements but order will be different. So the both the elements are, the both the sets C and D are equal. And D, F, D set having D, C, A, B and F is having A, E, I, O, U. So both the sets are not equal. In the same way, we can fill F and A not equal to D and E not equal to, because D is having elements D, C, A, B and E is having elements A, E, I, O, U. And F and B, these are also not equal because F is having elements A, E, I, O, U and B is having elements 1, 2, 3. Elements are not same. So thus two sets are not equal. Third question, in each of the following, here in each question two sets are given A and B. Now we have to state whether A equal to B or not. In the first question, A is having four elements, A, B, C, D. B is also having the same elements, but order is different. So both the sets are equal. So we can write here A equals to B. And for the second question, A is having 4, 8, 12, 16, and B is having 8, 4, 16, and 18. So the elements are not same. 8 is there in both the sets. 4 is also there in both the sets. 16 is also there in both the sets. But 12 belongs to set A only and 18 belongs to set B only. So these two sets are not equal. And from the third one, set A having 2, 4, 6, 8, 10, and B is given in set builder form. So we have to write the elements. So X is a positive even integer which is less than 10. Means we can write the elements as 2, 4, 6, 8, 10. It is only less than 10, not equal to 10. That's why I have to write up to 8 only. So by comparing these two sets, 2, 4, 6, 8 are equal in both the sets, but 10 belongs to set A, but that does not belong to set B. So these two sets are not equal, A not equal to B. And in the next question, X is a multiple of 10. Multiple of 10 means you can write 10 ones are 10, 10 twos are 20, 10 threes are 30, 10 fours are 40, like that, and so on. And in set B, elements are given 10, 15, 20, 25, like that. So from set B, if we observe, 15 is there in set B, but that 15 is not there in set A. So we can say that simply A is not equals to B. In the fourth question, two sets are given and mentioned that sets are not equal to each other. So you have to identify why these two sets are not equal. Try to solve this one. These are the questions from SSC previous public examinations for 2 marks and 4 marks. Practice these questions.